Hello, hello. Yeah, so I guess we can start our meeting today. So, good evening, all. Welcome to week 9 problem solving discussion session for our NPTEL PMRF course, which is NOC 25330 Geotechnical Engineering to Foundation Engineering. Myself, Rituraj Singh Sujawat. I am currently being acting as a Prime Minister Research Fellow in Department of Earthquake Engineering from IIT Roorkee. The course is currently being tutored by Professor Dilip Kumar Bedia, who is Professor in Department of Civil Engineering, IIT Kharagpur. So those who are joining the sessions for the first time, let me tell you, the objectives of these sessions are particularly meant to interact with the learners. Uh, we'll be discussing some of the important concepts which will be required to solve the assignment problems for that particular week. We will also be solving some of the sample questions. Those sample questions will be revolved around the course content which has been discussed in that particular week. Apart from the questions, if you have any technical doubt, please feel free to raise your query. We'll also discuss that particular part. Uh, Also, apart from your technical part, if you have any other tech query related to the course, or like let's say the career oriented query, or if you want to have any general discussion on the subject, please feel free to discuss. So this week's session is also meant to discuss the problems related to the deep foundations. So today we'll be solving some of the questions. So last week we have dealt with the assessing the capacity of shaft friction as well as the tip bearing capacity, shaft friction and the tip bearing capacity for the single pile foundation. Today we'll be discussing about the capacity of the pile groups, and we will try to see like how to assess the uh, how the shaft friction and the tip bearing capacity is behaving in the pile group foundation. So let's start with our course today. So the question number one for today part is like to assessing the efficiency of the pile group. So you need to select one of the option like on which the efficiency of the pile group depends upon, whether it is the dimensions of the pile or spacing of pile or type of soil or all of the above. So the correct answer is all of the above. guys, there's some issue with my stylus. Let me check. So the correct answer is all of the above. So the efficiency of the pile group depends on the dimension of the pile, spacing of pile, type of soil, as well as all of the above. So the next question which is there is, the load carrying capacity of an individual friction pile is 500 kilonewton. The total load carrying capacity in a group of 9 piles with group efficiency of 0.85 is. The load carrying capacity of an individual friction pile is 500 kN. The total load carrying capacity of a group of 9 piles with group efficiency of 0.85 is. Hello, hi Avi.
Hi, sir.
Hi,
Good evening.
good evening. So today we'll be having some questions related to the pile group foundation. So we'll be discussing some of the questions related to that only. Yeah, so let's check the answer. Yeah, so the answer is 3825 kilonewton. So total load carrying capacity of 9 piles is 0.85 into 9 into 500. So pile group efficiency is 0.85. So it has been asked like the total load carrying capacity of a group of 9 piles. So in that case, the efficiency is 85% and individual friction pile is 500 kilonewton. So definitely the in most of the cases the load carrying capacity of group pile is less uh, as compared to the if we take the individual sum of the individual capacity of pile. So that's why this efficiency we need to analyze, and it has been given as 85%. So the total load carrying capacity of 9 piles can be evaluated by multiplying the efficiency with the capacity of each pile and then with the total number of piles. So this is 0.85 into 9 into 500. So it is given by, so it's 3825 kilometer. So correct answer is C. So next question which we are having, a 500 diameter with 9 meter long pile is driven in a normally consolidated clay deposit of great depth. For the soil C is equals to 50 kPa, adhesion factor alpha is equals to 0.8 and the factor of safety of 3.0. You need to calculate the allowable load carrying capacity of the pipe. Question 3. Question 2. Okay, the question 2 it is. So let's check this. So it has been given you are having a 500 diameter 9-meter long pile which is given in a normally consolidated clay deposit of great depth. The soil is having cohesion of 50 kPa, adhesion factor alpha is equal to 0.8 and the factor of safety of 3.0. So diameter is 500 So what has been asked? The allowable load carrying capacity of the pile. So pile capacity is given by tip bearing capacity plus shaft friction capacity. So your tip bearing capacity is, so it's a normally consolidated clay. So its tip bearing capacity, factor of safety, adhesion factor alpha. So your tip bearing capacity is given by C and C, area of your base, and your shaft friction capacity will be given by adhesion factor alpha with your C value, and then you are having okay, area of shaft, right? So yeah, so your C value is 50 kPa. How much is your ANSI value? It's 9, right? Then your area of base is given by 0.784 pi by 4 into d square, which is 0 0.5 square. Then you are having addition factor value as 0.8, and then you are having cohesion value as 50. Surface area is your pi dl, so pi into diameter is zero point 0.5 and your length is 9. So how much is the value? Pile capacity which I am getting is 653.68. So that allow 653.68, and for the capacity allowable load carrying capacity, you need to include the factor of safety, which is 653.68 by 3. So answer divided by 3, so it's coming out as 217.89, which is approximately 218 kilonewton. So the correct answer is A, 218 kilonewton. Now let's move to question number 4th. Okay, Yeah, so question number 4 to 6 are of same, like it's having a similar data set. So you are given with a 40-meter long with a 500 diameter pile which is driven in a uniform deposit sand of friction angle 40 degree. The unit weight of the soil is 19 kN per meter cube and the water table present at very much below the tip of the pile. Given the NQ of 137, phi dash is equals to 40 degree and K is equals to 2 and delta is equals to 0.75 phi dash. You need to determine the critical length of the pile. I guess we have dealt with such type of question like in our previous class. Let me check. Fourth, critical length, Q friction, Q tip. Yeah, so I think we can skip this. Let's have another set of question. Yeah, I think we can go with this. So a pile group of 9 friction piles of zero point 0.4 diameter is embedded into the soil with an arrangement shown in the figure. The settlement of the group is compressibility of the sand and assume the stress distribution as one horizontal with two vertical. Consider the unit weight of the water is 10 kN per meter cube. Uh, you need to determine the settlement of the group. Right.
Sir, can you zoom the diagram, sir?
Yeah, I'll just do that.
Slide itself you can zoom, sir, so that
Mm,
temporarily you can zoom the slide.
I'll do that.
Yeah, now it is better, sir.
Yeah,
Thank you.
no worries.
It's better, sir.
Okay. we'll just solve within 2 3 minutes. Let's wait for this. So in this particular question, if you see, you are having a pile group of 9 friction piles of 0.4 meter diameter is embedded into the soil with an arrangement shown in the figure. Okay, this is the particular arrangement. The settlement of the group is neglecting compressibility of the sand and assume the distribution as 1 horizontal and 2 vertical. Considering that the unit weight of the water is 10 kg per meter cube, so it has been asked. Yes. So here, like it has been said, like we are basically neglecting the compressibility of the sand. So whatever compressibility we need to consider the for the clay soil only. So for that part, like to determine this, if the our pile group is subjected to certain vertical load, then whatever load is being get transferred, it's getting transferred to the clay soil, and the settlement of the foundation is happening due to the settlement of the clay soil. So to determine the corresponding settlement of the clay soil, you need to assess the equivalent projected area of the pile group foundation. In that particular case, uh, your projection, if you see, so let's say this is your base of the pile group foundation. So the total dimension of the footing is 0.9. 0.9 is the spacing, how much is this particular area? So zero point 0.9 plus zero point 0.9, so this is zero point 0.9 again, and this is also zero point 0.9. Oh sorry, diameter we need to take. Yeah, so since we need to see the projection from here, so that is the
Both the
part which,
sides, point to, na, sir?
yeah, so
Divide to divide to.
yeah, so total B will be zero point 0.9 plus zero point 0.9 plus your 2 times, or like diameter we can take, or 2 times of
Okay.
radius. So that is zero point 0.9 plus zero point 0.9 plus 0.4. So that is basically 2.2, right?
Yes, sir.
Yeah. So the projection area which you need to consider is from here. So it has been said like this is basically following one horizontal and two vertical, right?
Yes, sir.
Yeah. So if we see, so basically we need to take the projection of this square area. So this is your square area, and if you project something like this, this is the we need to determine. So this is your B dash, B dash, B dash, and B dash. So if you look for that, your B dash value will come out as, so first you need to take this part. So B dash, like first you need to project 2.2 and then look twice of your two vertical, one horizontal. So your horizontal is how much? So twice is your vertical. So it's basically we need to determine this depth from the bottom. So 12.
Below the pile up to center line, sir.
Yeah, so this depth we need to consider.
Hmm. It comes 5 meters.
So this is 10, 2, 1, and this is 2 meter, right? Yeah, so this is
Hmm.
5 meter. So again if we go with that, so twice of 1 by 2 into 5 meter, right? So your total B dash is 2.2 plus 2, 2 will get cancelled, so this is your 5, so this is your 7.2 meter. So your B dash will come out as 7.2 meter. So the corresponding total load which is, or like the stress which is coming to your clay layer now can be calculated is, so the total
It
load
is
is
it is
500,
given, sir. It is
500
given on the top of the pile.
yeah. So Q dash will be your Q by B dash into B dash, right? Your
Yes, sir.
Q on the your, what we say, on the top of your pile group is 500 kilonewton, and your B dash into B dash 7.2 into 7.2. So your Q dash will be 7.2 divided by 7.2, which is basically your 96.45 kilonewton per meter square. So yeah, answer is 77 mm. Let's solve this. So we know the settlement of the clay layer is given by delta H is equals to Cc dash H 1 plus E naught, your logarithmic of sigma dash plus delta sigma upon sigma dash initial, right? So your clay layer, the Cc value, so delta sigma we know. Now we need to find how much is your effective stress. So we are also having water table. So sigma dash at center of clay soil is given by 10 to 12 into your gamma is 20 kilometer per meter cube. Then you are having water table for 1 meter. So 20 minus 9.81. How much is the
10 is given, sir.
10 is given, right? So it is 10, and this is 1 meter, right? Yeah. And then you are having clay soil is 2 meter, and again water table is there. So the gamma is same for both of them. So yeah, it will be also 10. So the value will come out as 12 to 40 to 40 plus 50 is it 290. Yeah, so basically this is 290 kPa.
270 will come, sir.
110 20
First is 240 plus 10 plus 20.
plus 10 plus 20, sorry, yeah, it's 270.
270 will come.
That's 270 kPa. Then your cc dash value is how much? It's zero point 0.3,
0.3.
and your height of the layer is 4 meter, right? Then your e naught value, which is given, is 1.05, 1 plus 1.05. Then your logarithmic value, sigma dash value is your 270 kPa plus delta sigma is how much? 96.45, which you have evaluated. And your initial effective stress is also 270 kPa. So your settlement of the layer can be calculated as 270 plus 96.45, answer divided by 270, logarithmic of answer into zero point 0.3 into 4 divided by 2.05. Yeah, so I am getting it as 0.0776 meter, which will come out as 77.6 mm. So it is closer to option B. Yeah, so correct answer is option B. Then any doubt in this, guys? Anything? Yeah, if not so, then I think we can move to our next question. Yeah, so this is the theoretical question. You have been asked, you like, for supporting the cantilever sheet pile, uh, what is the basic mechanism? So let's see this. So we have some answers. The answer is A, given by AIV. Yeah, so the correct answer is the passive resistance of the soil. So if we see the cross section of a sheet pile wall, it is usually embedded in this particular soil, and the sheet pile has been designed to resist the retained soil which is filled at the back. So the major resistance is given by the soil which is available at the embedded ground, and this is the particular soil stress which is acting on the pile, and this particular resistance is the passive resistance of the soil. So the correct answer is A, the passive resistance of the soil. Let's move to question number 9. So you have one given with an anchor sheet pile which is driven to a shallow depth, which can be modeled as, so the options which are available with you is free earth support, fixed earth support, roller support, or none of the mentioned. So what is the correct answer? The correct answer is A, it's a free earth support. Do you have any counter argument for that, ARV? Like with the answers available with
No,
you?
sir, I am not sure about this question because of modeling we didn't discuss.
Okay, okay, okay. Yeah, so I think your answer would have been correct if the sheet pile would have been driven to a very larger depth. So in that particular case, you can model it as a fixed earth support, but since it is driven to very shallow depth, so to being at the conservative side, like we can model it as a roller support, like
Okay, the
very
answer lies in the shallow and deep depth.
yeah, yeah, free earth support.
Okay, understood,
Yeah.
understood.
So in that particular case, like we need to go with this, it's free earth support. Then let's go for question number 10. uh, yeah, so you need to determine which region is the passive state in this particular uh, loading diagram. So you are having a sheet pile given to you, and the deflection profile is also given to you. Now among the four sections which have been marked, you need to determine which section is the passive section. Yeah, so let's see the correct answer. So if you see this particular diagram, so this is your sheet pile, right? When it is subjected to a certain load, so this section, if we see this particular section, like since it's rotating about this point of rotation, so when it is subjected, when your pile will move towards the soil, so as you can see this section is moving towards the soil, so this is your passive state, and this part is also moving towards the soil, so this is again the passive state. So this rotation, so as you can see, third as well as for the first, your pile is moving away from the soil, whereas the second and the fourth, your pile is moving towards the soil. So
Sir,
that's the difference.
first zone is passive one.
First zone is active.
Yeah, you then why you have written passive?
No, no, this is for the second zone.
Arrow mark
Arrow,
you kept
arrow is
plus.
like for the movement of the pile.
Okay, movement already deflected shape is given. Okay,
Yeah,
okay.
sorry.
Right, right.
So this is your movement. I'm sure.
Okay, okay.
Yeah,
Second zone is correct,
yeah.
passive.
So correct answer is D. Is your
Told.
second zone. Okay.
Yes, sir.
So let's move to our next question. So as compared to the cantilever sheet pile, the required depth of the anchored sheet pile below the dredge level is. So for the anchored sheet pile, whether the required depth of embedment is more or less same as compared to the cantilever sheet pile. So do we have answer 11B? So it should be less. Let's see why. Since this is your cantilever support wall, which is supported by the embedment depth, and this is your ground. So when your pile is anchored into the ground, as well as it is embedded into the ground. So let's say if this length is L1 and if this length is L2, then in our case, since the support is already being provided by the anchors which is embedded into the ground, so your L2 length will be less than the L1, because in your cantilever sheet pile, like the whole support has been provided by the sheet pile which is embedded into the ground. So that's why your L2 is less than L1, and that's why the required embedded depth in the cantilever sheet pile is less than for the required depth for the anchor sheet pile.
Sir, can I have a small interaction?
Yeah, please.
In cantilever, by reducing the L2 value,
Mm.
we are putting additional money on the anchor rod.
Yeah,
Cost point of view, it is a compensating. L2 we are reducing, but anchoring cost we are adding.
yeah.
Whereas in free earth support, we don't have an anchor rod cost, but
Mm.
L1 is increasing. Cost will be increasing.
Yeah.
So from the cost point of view, is it both the same or different?
That we need to check. Like again, it
Okay,
depends on
okay,
any
okay,
particular site. So it
okay,
not
okay.
only depends on the cost only. Yeah,
Hmm.
cost is one of the major factor, but it's not only the factor. So again, the availability of the material, like for the anchoring
Okay,
also
okay.
required the expertise, or like the transportation of the logistic is the another thing.
Driving charges and
Yes,
etc.
everything. So yeah, but
Okay.
I think as per my understanding, like if you are having all the conditions as same, then like for the cantilever you require more, like it's more costly because the amount of material which will go is very large. And for the anchors, like if you are having very well equipped machines, or let's say the technical instruments which can easily drive your anchors into the ground, then it can basically save your cost as compared to your cantilever sheet pile case.
Mhm.
So
Depends on situation. Both we can choose.
yeah, depends on the situation, like whether the how the ground is, or like the logistic,
Hmm.
or
Even maybe obstacles for driving.
obstacles for the driving. Yeah, definitely.
Oh,
Like when the ground which you are driving your anchors, like how feasible is the driving processes. That also depends.
okay,
So
sir. Done.
that also we need to look at.
What is your recommended reference, sir, for the sheet piles?
Like among both of them, like what we
No,
need to
no,
look at.
only for the topic of sheet piles. Are
For
you
the
referring any advanced books?
advanced book, there's one book, like I'm forgetting. It's from the ground improvement technique. So that's a very famous book. Let me
Okay, sir.
check that.
Some other time you can mention. No problem.
Yeah, yeah. I'll just check and let you know. Like,
Okay, sir. Done.
yeah, yeah, yeah. Yes, Kupika. Hello.
Sir, I found the error in the code.
Mm-hmm.
I will rectify it today night. I have
So,
sent you the error in on WhatsApp.
is it coming? Like your file is running in
No, sir,
Paraview?
I have there is like an error in the code, like how you have structured the code.
Uh,
Like your I don't know.
I'll meet you at 8. Like, right now, are you here?
I'm going to my room, sir.
So
But
let's
I've written the code
so
error.
we'll meet online. Okay,
Okay, sir.
it's fine. Okay.
Okay.
Sorry. Okay. Yeah. So let's move to question number 12. So this is a question. So for the cantilever sheet pile wall, which is shown in the figure, the point of zero pressure will be at a depth below the dredge level is. So you need to define the point of rotation about which your cantilever sheet pile is being rotated. So what is that point of rotation? So that is your point of zero pressure, which you need to determine.
करो ना, मैं सर को मैसेज डालता ना, मेरा फ़ोन लेके आना ऊपर है उठे बोला है।
I could not spend time on this as an example still.
Which one? Question number 12?
Yes, sir.
What happened? So,
You can start, sir. I could not spend the time on this.
so let's wait for 2 minutes. I'll solve this here. Okay, then let's just check this. Yeah, so let's check the answer. Any answer, guys? So, the depth below the trace level, how much it is? So, it's 1.05 meter. So, let's check this. So, basic idea behind solving these particular questions are, like, let's say if you are having the sheet pile wall, this is subjected to certain passive pressure, as well as you will have a certain pressure from here. So you need to evaluate the equivalent force which is acting on that pile, and the pile and the equivalent force which is acting on the pile from this side of the soil, and then you need to counterbalance both the forces and need to see the resultant point where these forces will be acting. Or also you need to calculate the moment about that point, such that the moment which is coming from the force from the right hand side and the moment coming from the left hand side will get equal. So let's solve this and understand that. So if you see the pressure diagram, So this is your sheet pile wall, and this is your ground, right? So if you see, the amount of pressure which will be acting will be like this, and you will be having certain pressure which is available. Like, then first you are having passive pressure, then your pressure will get reduced because your passive pressure from this side will try to get dominate, and then you will be having profile something like this, right? So stratification is given, like it's P is gamma is 18 kN per meter cube, gamma set 20 kN per meter cube, then gamma dash is given to you. Okay, phi is 30 degree. So for our case, yeah. So in this particular part, first you'll be having P1 pressure from here, then you'll be having, so from this depth you'll be having certain load, then from here your force will try to get dominant. Sorry for delay, like I got confused in one of the parts. So this is your P pressure, passive pressure will be acting, then this one will be P passive pressure, then this one will be P passive pressure. So your PAC, which will be acting on this part, is your 18 into 3 plus tan into 3. So you need to calculate the pressure which is acting, and that will be multiplied with the K value. So the friction angle which is given to you is 30 degree. So your K value will be 1 minus sine phi upon 1 plus sine phi. So if my sheet pile, okay, this will be the active pressure because your pile is moving away from the sheet, and in this particular case also, here your pile sheet is moving, here is also your P active will act, and then here you will be having the passive pressure. Yeah, so this we need to counterbalance since your pile sheet pile wall is moving away from the soil. So here you will be having active pressure, here you will be having the active pressure, and then here you will be subjected to some passive pressure. So for your K is 1 by 3 and your Kp will be, it's basically 3. Yeah. So your A value is basically given by PAC, which is your gamma dash Kp minus Ka. How we are getting this? So let's look into that. So this is your gamma dash. So PAC is given to you, then this PA, another P active 2 will be your 10, and then you don't know how much is this value. So let's assume that at the dredge level it is not given how much it is. So let's assume that this is 10, this is A, and then this is your PA3, or let's say PP. This PP and this will be multiplied with your K, and is the force given to you how much? 3 0 pressure. So this will be your Kp, and this is your 10, and this will be given by how much is this depth? Okay, let's solve with simple mechanics. So assume that if I am having this depth as L, then your this depth will be L minus A. Okay, or we have been asked A, so this depth will be your L minus A. So your P active pressure is 18 into 3, 18 into 3, so this is your Kp. So this is the total pressure which will be acting, and then this force which will be acting is Pa, which is 10 into 8 times of Ka. Okay, and then this passive pressure will be Kp, so this is your 10 L minus A into Kp. Okay, now basically we need to equate these forces. So your PAC is equals to PA2 plus PP, right? Now the only problem is we don't have the L value available with us. So your 18 into 3 is 54 plus 30 into your Ka. Your Pa2 value is your 10 into Aka, and plus your this value is 10 into A into Kp, and this will be, sorry, this will be minus, and this will be plus 10 into L into Kp, but we are not given with the L, so how to find the L? It's a 3 meter, 3 meter, 3 meter. The point of zero pressure will be at a depth below the dredge level. So if we see, this is the point of zero pressure, I am having that direct formula, like with the value of A equals to PAC, and then you can subtract the gamma dash.
That is without water table, sir.
Which one?
Whatever you are writing is without water table or with water table.
It's
A is equal to PAC by gamma dash Kp minus Ka.
it's with water table.
With water table. Okay, right.
So I can solve with this particular part, but I wanted to show you the mechanics, but I don't know where the L factor has been gone to this formula. So okay, I'll look upon this and will tell you. But for timing, like this is how you need to proceed. So for calculation of the A, like where the point of zero pressure, you need to calculate PAC. So PAC is basically your 18 into 3, which is 54 plus 30 into Ka is your 1 by 3, then your gamma dash is 10, then your Kp value is again 3 minus 1 by 3. So you can directly get the answer from this formula, but I just wanted to look upon like how they have equalized the pressure. So
Okay, sir. You can do it in next class. No problem.
yeah. Okay, so you can solve it using this formula PAC gamma dash Kp minus Ka, which is 54 plus 30, answer into 1 divided by 3, answer divided by 10 into 3 minus 0.33. So it will give you something around 1.05. So the correct answer is option D,
What is
1.05.
that PAC, sir? AC means
PAC is like how much is the
active
pressure available. Yeah, active
at,
pressure available
at,
at the base of the
at a
wall.
point of C.
See this one at this point.
Okay.
Yeah,
At the dredge level.
at the dredge level.
Okay, sir. Understood.
Yeah. For timing, I'll just rough this part so you guys don't get confused. So the A value is 1.05 meter. So let's move to question number 13. So it's a similar question. So the depth of the embedment for the sheet pile below based on the simplified method for the earth pressure. So you need to calculate how much is the D value. So let's say if you are having this, do you guys have any answers? 13D. Okay, let's check this.
Small mistake I have done, sir.
Yeah,
I will check it.
it's 9.26 which I'm getting. Can I solve? Or you want some more time?
Yeah, if you give 1 or 2 minutes, I will clarify, sir.
Okay, okay, no worries.
Yes, sir. It is C, sir.
Let's see.
Yeah.
How did you solve this?
Equating the pressure distribution diagram on both the sides, sir, with respect to bottom.
So you might be getting the cubic equation, right?
Yeah, I will tell you the equation.
Yeah.
9d cubed is equal to
Mm-hmm.
10 plus d whole cubed.
Okay, okay. Then
Then
it's
directly I am substituting options, sir,
okay,
instead of
okay.
solving the equation,
Huh.
so
Then
that it will be simplified.
then it's nice. Yeah. Yeah, because otherwise it's becomes very problematic.
Yeah, it will take time otherwise.
Yeah. So guys, let's have a look on this. So you have been okay. sorry guys. Okay. Sorry guys, there's something wrong with my styles. I'll just check this. Yeah. Now check. So you have been given with this particular diagram.
Screen share, sir.
Yeah, sorry. So this is your stress diagram. Something will look like this. And then this is it. So here you are having passive pressure. Okay, here you'll be having active pressure, and then you'll be having the passive pressure. So I guess in the last question, I guess we have drawn the stress diagram as wrong. So that's why there was an issue. There was issue. So you guys can go proceed with this stress diagram, and then you can solve the query.
Last case, it is not mentioned, sir. Simplified approach is not mentioned.
Okay.
That is why it becomes a complicated.
Here we are assuming like that.
Yeah, here it is mentioned clearly, simplified approach.
Huh. So yeah, then we can go with this. Okay, the answer is 9.26. So your P active is basically half times of first you need to calculate the pressure. So pressure is your K into gamma into tan plus D, and then again you need to multiply it with the height tan plus D, and yeah, for calculation of the area you need to take half into, and then you need to multiply it with the height. So this is corresponding to your pressure, this is your tan plus D is your height. So your P active is basically half times of pressure into height.
What is the first line, sir? What you have written? It is the force or moment?
It's a force.
Oh, force
So
is half into base into height only, na? Why again 10 plus
sorry,
d?
so yeah, 10 plus D is then for moment you need to multiply it 1 by 3.
In that case, left hand side you have to write as a moment, not pressure.
Yeah, sorry.
Yeah, moment about the base.
Yeah, so this is your
Yes.
bottom is your B pen. So this will be your B point. Let's assume. So
Hmm.
moment about B
Uh,
is your this minus, okay, this will be 1 by 3, and then minus half into Kp into gamma is same, then this is D, then this is again D,
yeah.
then yeah, it's D,
D by 3.
It's 1 by 3, right? Yeah,
Yes, sir.
half into q. So then this is your sigma mb, and you need to put the sigma mb is equals to 0. So once you are having sigma mb as 0, then this will be some cubic equation, and then you can solve this and you can get what is ever the value of d is. So you can either perform this task in your calculators, or as ARV has suggested, you can directly put value by value and get the suggested answer. Like you can put the LH is equals to RHS for the different values of d. So the answer which we are getting is option C, 9.26 meter. So this is a simplified approach where you take the moment about the base of your sheet pile for both the active pressure and the passive earth pressure, and then for the corresponding part you evaluate how much is the value of your embedded depth. So ARV, you are
Sir.
in industry, right?
No, sir. I am an academician, sir, actually.
Actually, you are an academician.
Academician, yeah.
So you are professor or like
Associate professor, sir, in one of the private college in
okay, okay, nice.
South.
Okay, okay. No, some people were there from industry also, like
Yeah, I have
uh,
seen Raghavan, I think Vijay Raghavan, or
yeah, yeah,
he asked last time some doubts, I remember.
yeah. Vijay, are you
Yes, sir.
there?
Yes, sir. I mean, metro rail.
Yeah, he's in industry.
So can I ask like how you guys in industry basically do this returning work?
Sir, we are exhibition only. We have a detailed design consultant is there.
Okay,
We will provide this geotechnical. Now we are doing the geotechnical GTI for alternate piers along the stretch of the 44 kilometer. We are doing the GTI
okay.
geotechnical investigations
So are you guys
for
you are in investigation, and like are your any particular segment is in design also?
the design hereafter only it will come as far as now in this project is concerned.
Okay,
I'm not in design. Here
okay,
we have that detailed design concerns are there. Three packages, three team has been done. Tendering they have selected three teams,
okay.
and now we will provide this geotechnical data. They will design for
Okay.
peers. They will design
So your
file and
your
detailed.
firm is basically associated with the geotechnical investigation only. It's not in the design
No,
part.
I'm civil only. I'm civil actually.
Okay.
This is a part of a job, so that I want to go about this level.
Okay. Yeah. Yeah. Okay. Got it. So just want like I am just curious like how they basically operate in industry, like
Now
okay.
only they will decide about this pile and all. In some area we are having earth up to soil up to 30 meter. In that area we are going taking the bore up to 30 meter. In rock area we will go up to the rock area and further 5 meter depth we will go. We will get the lab test also they are doing.
Okay. You are
This
involved in lab test also.
I'm not involved, but it is going on. That soil test they are doing that, and untrained unconfined compost system.
Mm-hmm.
All we are they are submitting that report also. Now only I'm going through that
Okay.
interim report. For
Mm-hmm.
every 10 GTA, they will give one report, lab report.
Uh-huh.
Soil box limit, all other things.
Okay.
Disturbed some, undisturbed some. What are the tests required? They will do as per IS code,
Okay.
and
Nice.
they are submitting.
Nice.
This soil report will be interpreted by the designers, like I
Mm-hmm.
think you people, like design engineers,
Yeah.
and they will design the pile depth at every 28 meter we are having on piers.
Mm-hmm.
It is a double decker. At
Okay.
first level, it is a metro, and second level, it is a second level, it is a metro. First level, it is a road.
Okay.
Road come rail project.
Okay. Got it. So you are
It
majorly
is,
into investigation,
a lot
geophysical.
of work is there.
Okay, nice. So, like, what's your role is in that particular firm, if I may ask?
Sir,
What's your role in that particular firm?
my role is in execution only, sir. I'm in charge
Okay,
for a stretch.
okay, got it.
Yeah, I have engineers. We will be doing this GTI pile foundation, pile cap, pier shuttering, concreting.
Okay, okay, okay.
Previously, I have done one stretch, 6 kilometer stretch of metro rail.
Oh, nice.
In that, I have done pile foundation, pile caps,
Hmm.
viaduct also. Viaduct not fully involved. Only some part I have involved in launching of girders.
Okay.
In stations, we have 10 numbers of pier.
Hmm.
Pier after that, pier arm stressing will be there.
Okay.
Stressing of pier arms.
Uh-huh.
Above the deck flag will be there. Above that, concourse level, controls level. You have to again go for this pier and track level will be there. All our construction we will be doing as per drawing,
Okay, okay, okay.
including finishing work also. Architecture works also we have done,
Hmm.
and we will be do the commissioning
Okay.
open for the public.
Got it, got it, got it.
Not that much involved in this detailed
Design, in the design process.
design and all.
Yeah,
But
same.
I am
Same
interested
here.
in this and all. When you see the report, then only will come to know this detail. We should know as
Mm-hmm.
a engineer.
Mm-hmm. Okay. So
It is
when
a
you,
teamwork, I think.
yeah, they are basically means delegating their work.
Yeah.
Their firm is majorly involved in the investigation part only, which I guess. Okay, that's great. So when we come to
So,
the topic of
in this,
technical investigation, we might trouble you in that case. So we'll see the insights from your experience also. Yeah, yeah, Vijay, you were saying something. Sorry.
no, no, if there is, I will. We are having that report in next class. I will ask any if there is any doubt in this that interim report. That is a report only.
Okay, 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 okay.
Lab technical there.
Great, great. We'll discuss at that time.
Okay.
So yeah, I think it's already 8, so we can wind up for today. If you guys have any doubt, please feel free to ask. Else we can meet on next Tuesday, 8 CST on same.
In this week class, problem is in this week assignment problems. We are not. I think you have not discussed. It is already in the lecture. Also.
Uh,
That efficiency and all you have discussed.
uh, what was the topic for this week? I think it is the pile group foundation only, which I guess.
In this week assignment 9. This the sheet file is in week assignment 10.
Okay,
Similar topics are there, sir.
okay. Let me check. Let me check.
Yeah, similar topics are there.
Yeah,
Almost similar.
there might be overlapping of the topics, I guess.
9 file group efficiency. It is already in the lecture. I have to see another two lectures are pending from my side. I have to study. I have already gone to all the lectures.
Okay,
Next week, one lecture is there on pile foundation, and this week, in that, I think some problems are not there.
okay. This
Allowable block capacity is there now. Okay.
Yeah, yeah, yeah. So this
Uh,
week 10, week 9, lecture number 2.
okay, okay, sir. Okay, I will see the.
Yeah, I'll just check. So your assignment 9. Yeah, I guess there are some question concerning with the pile group.
Pile group efficiency.
Yeah, so these are the similar questions which we have discussed today. Like,
Maybe Vijay sir is asking about converse Leverage formula.
That one is easy. That one is in the beginning. It is there. Ninth
Yes,
one
sir.
also it is there. Ninth.
yeah,
Two
yeah.
questions are there and
Question number
converse
nine.
Leverage formula.
That same formula has to be used for this question number 9 also.
Yeah. So you are having, I guess, in the lecture notes, the formula is given to you.
That converse I know that I have see the lecture.
Okay, okay.
Professor note I have seen that one.
So that you might be having the access to of formula
Question,
from the lecture
question
notes.
number 9, sir. Vijay sir.
Yes, sir.
Question
Yes,
number
tell me, sir.
9 is similar to the what we have done today.
It is done in one and question number 1 and 2. Okay, okay. I will see.
Question number 9 in our assignment is similar to the today's topic what Sir has done.
Yeah.
No, sir has gone to sheet file one. He's after
No,
that
no, no.
question number
Initially,
4.
first example, I think you are late maybe 1 or 2 minutes. One
So
example, first one
then
or two
half
example.
an
You
hour
can go through
later.
the uploaded video.
Okay, 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 sir. Anyway, thank you. I will see that. I
Welcome, sir.
will.
Yes, you might
Thank you very much.
like I'll share the slides and you can also refer the video for after session.
Tonight you will be loading, sir. Tonight.
Yeah, I'll upload it right away, like just within 1 hour you get the access to
Okay,
it.
okay. Thank you very much.
Okay.
Thank you, ARB.
Thank you, sir. Thank you, all of you.
Yeah.
Thank you, thank you.
Thank you all of you. Thank you for joining. And those who are
Thank you, sir.
watching these videos at a later stage, you can put your queries in the comment section. We'll address those queries there itself. So I think we can wind up for today. Thank you again for joining. We can
Thank you,
call
sir.
it a day. Okay. हाँ तो कर लो जो करना ड्रामेबाज